Good afternoon, everyone. Thanks for joining the Micron Minute today. My name is Holly. I'm an XRM application engineer at ZEISS Microscopy Customer Center in Dublin, California. So today I will give you a quick introduction of our newest XRM system, the 630 𝗿𝗁, with a video. So this is how the 630 𝗿𝗁 looks like. It's a very powerful, non-destructive 3D X-ray imaging system, can be used in different areas, such as semiconductor, oil, gas, and battery. The system mainly includes three parts. So this is a temperature-controlled enclosure where we load and image our sample. It's made of steel and light to protect us from the harmful radiation. And a high-performance workstation, so which we use to control the whole system through different software. We can use this software to collect image, do reconstruction, and also check metadata. And this is a light tower, shows the status of the whole system. So when the green light is on, means the system is powered up. And when the yellow light is on, means the door interlock is engaged. And when the red light is on, means the source has been turned on, the X-ray has been turned on. So let's have a look at what's inside of the enclosure. So in the enclosure, there also mainly include three parts. So the left part is the X-ray source. So the 630 𝗿𝗁 equipped with a polychromatic X-ray source can go up to 160 kV and 25 watts. And it also equipped with automatically filter view. So by using this X-ray source filter and the software, we can correct the beam hardening artifacts generated by the polychromatic X-ray. In the middle of the enclosure is a sample stage. So the 630 𝗿𝗁 equipped with a 4 degree of freedom sample stage can move in X, Y, Z direction and also rotate 360 degrees. So by using this sample stage, we can just zoom in any location of your sample, run a very high resolution internal tomography without remounting it. And on the right of the enclosure is a detector. So the 630 𝗿𝗁 equipment with both 5-panel and different objectives, designed for different resolution and field view. So usually for common micro CT, they only use the 5-panel detector. By changing the position of the source and detector, we can get a different geometric magnification. However, if we want to run a high-resolution internal tomography of a large sample, it's impossible because we cannot move the source too close to the region of interest. So for this situation, we can use objectives. So after X-ray penetrates through the sample and received by the detector, we use a scintillator to convert X-ray to the visible light. And then we use different lenses to get a different optical magnification. So because we have both geometric and optical magnification, we can get a very high resolution of an internal area of a large sample, which we call resolution at a distance. For the 630 XRM, the highest resolution we can go is 450 nanometer, and the smallest voxel size we can go is 0.2 micron. So because we use a 5-panel, we can image very large sample up to 140 by 165 millimeter. And when we use the 630 𝗿𝗁 XRM to image sample, so X-ray will penetrate sample received by the detector, and the part of X-ray will absorb by the sample itself. So because the density difference between different part and the material of the sample, the greenness will look different on the 2D projection images. And also, the difference between the XRM and the medical CT is that we only rotate the sample instead of source and detector. So we collect different 2D projection images at different angle. So just like this, we get different 2D projection images at different angle. And then after we collect all these different 2D projection images, we use reconstructor to reconstruct them together to generate the 3D data. So this is a full field of view 7-micron resolution 3D data of the mouse embryo. And for the 630 XRM can also equipped with the autoloader. So the autoloader, we can load the maximum 14 different samples on it. So by creating different recipes for different samples, we can use the autoloader to load these 14 different samples automatically one by one and image them one by one. So we don't need to come back during the night or weekend to change the sample. Now let's have a look at our software, which we use to control the whole system. So this is 𝗦ci𝗰𝗶𝗹𝘀, the software we use to control the whole system and collect image. So on the top of software shows the status of the whole system. And the left part shows the workflow, which we use to collect the data. So we need 5 different steps to collect the image. So because the 630 equipped with autoloader, so we can either use an autoloader to load the sample, or we can load the sample manually. And also 𝗦ci𝗰𝗶𝗹𝘀 give us guidance of how to mount the sample. So all you need to do is let the system know what's your sample size, what's your sample shape, and the density. It will give you recommendations such as which kind of sample holder you need to use and how to mount it. And with 𝗦ci𝗰𝗶𝗹𝘀, we have both Smart Shield and the Smart Shield Lite. For Smart Shield, we use variable light to generate a digital envelope or digital model of your sample. So it will let the system know how big is your sample, and when we move it, the system will know where it is. So it will prevent the collision between the source detector and the sample itself when we move each other. So this is how the digital model looks like. It looks exactly the same with the sample. So except the Smart Shield, we also have the Smart Shield Lite. So for Smart Shield Lite, we don't use variable light to generate the envelope anymore. So we use a digital envelope tool to manually create an envelope. So the reason why we have both Smart Shield and Smart Shield Lite is because we use variable light to create an envelope. So we cannot use Smart Shield for something like a very shiny transparency sample. So for this kind of sample, we can use Smart Shield Lite. So this is how the digital envelope looks like when we use Smart Shield Lite. It's a perfect cylinder. Looks very similar with our sample. And for the 𝗦ci𝗰𝗶𝗹𝘀, we have 3 different ways to collect the image. So first is 3D volume scout, 2D projection scout, and manual scout. So usually for other X-ray imaging system or micro CT, we use 2D projection image. By using this 2D projection image, we check the transmittance and the intensity, and decide what kind of parameter we're gonna use and which source filter we need to use. However, by using this way, we need to know a lot of X-ray imaging knowledge and experience to select the most suitable parameters. But for 𝗦ci𝗰𝗋𝗆, we have other 2 different ways. One is projection scout, one is volume scout. So for projection scout, all we need to do is move the sample to the center of the field of view first, and then the system will collect 2D projection image at both 0 and -90 degrees. After that, we use the ROI tool to select which region we want to run a high-resolution internal tomography. So after select the region of interest, the system will give us recommendations such as which objectives we need to use. For this internal tomography, the system recommends us to use the 4x objective. And also it gives us the relationship between the resolution and the scan time. So after deciding the region of interest, the field view, the 𝗫ici's gonna scan the sample at different image the sample at different kV and collect the image and the reference image. So after that, it will give us 3 different recommendations. So first one is better image quality. Second is the balance. The last one is fast mode. So you can see the high image quality recommendation is very long compared with the faster scan. And also we can check the 2D projection image of these 3 different settings. So by comparing these 3 different projection images, you can decide which one you prefer. So after you select it, the system will run according to this recommendation, use exactly the same parameters. And also we have the volume scout option. So for XRM, it's a 3D non-destructive imaging system. So sometimes it's very hard to figure out where is the feature, where is the region of interest we want to image according to the 2D projection images. So for this kind of situation, it's better to collect the 3D data first and then locate the region of interest of features according to the 3D data. So for the volume scout, we can either gather a quick tomo overview scan, or we can just open existing overview scan. So if we want to gather a quick tomo overview scan, the 𝗫ici's is gonna run it by itself. It will ask you, so how long you want to finish this scan. So you can either do it a 1-minute scan, or you can do custom. So after it collects the image the sample and then collect the data, it will load the 3D data to the embedded 3D viewer. So as you can see, there are 4 different windows. So the top right window shows the 3D rendering of this quick tomo data. So this is a mouse embryo sample. So this is a 3D rendering of this sample. And the other 3 windows shows the virtual 2D cross-section view from different directions. So this window, the bottom left window shows the virtual 2D cross-section from top to down to bottom, and the other 2 windows show the virtual 2D cross-section view from side directions. So after that, we can use the ROI tool to decide to locate which region we want to run a run a high resolution scan. So it's gonna be much easier to locate your feature or region interest from the 3D data. So as you can see, by changing the size of the field view or region of interest, the pixel size is gonna change accordingly. And after we select the regiometry, the field view, it also can give us recommendation of which objective we need to use. So for this one, it will recommend us to use the 4x objective. Also, it's gonna give us the relationship between the resolution and the scan time. So we will know if we scan a larger field view, how the scan time gonna change. Is it gonna be longer or shorter? And after we decide the field view, it's also gonna collect the 2D projection images with different KV. So by collecting these different images, it will decide which filter is the best option for this imaging. And also by checking different 2D projection image at different KV, it will check also the intensity and the transmittance to decide the exposure time as well. So in the end, it also gives us 3 different options: better image quality, balanced, and a fast scan. So we can compare these 3 different 2D projection images and then select which one we prefer and use this as our imaging setting. And now let me show you 2 data sets which we collect by the 630 Versa XRM. So this is mouse embryo data. This is a full field view data with a 7-micron resolution. So this is a Dragonfly Pro software which we use to do the 3D, to verbalize the 3D data and also do image segmentation and analysis. So you can see same thing, there are 4 different windows. So the top left window is a 3D rendering of this data. And the other 3 windows shows the virtual 2D cross-section view from different directions. And also you can see there's a short bar on each of these 3 windows. So the bottom left is the green one, this is blue one, and the red one. So they are corresponding to the 3 different colored planes shows in the 3D rendering window. So when we move the green plane, you can see the bottom left window is changing. And when we move the pink one, you can see the top right window, which is a top-down view, is changing. So this is a 7-micron resolution full field view data. So as you can see, with this resolution, we can distinguish different organs or different features of this mouse embryo sample. So this is a heart, and this is a kidney. And also because we have the Scout zoom function, we collect another data set of the heart part with a 1.3 micron resolution. So this is a high resolution data of the hard part. And then we can have a comparison between the high resolution and the low resolution data. So you can say with a higher resolution, you can see more details. So more features, and also the contrast between different phases and the interface between different materials is gonna be much more sharper. And also you can say the low resolution and high resolution data has a very perfect match. So that's because we are using the full degree of freedom sample stage. Okay, thank you. So we have more coming ZMCC workshop. So you can use this QR code to visit our website to see the upcoming ZMCC workshop. And also we have the Micro Minute every week, every Thursday, 1 p.m. So please let me know if you have any questions. Okay. Thank you, everyone. So hope you have a great day.